Hi, this is Mr. Ward, and we're going to talk about number 2 and a couple other linear function related questions from the 2021 released items of the 8th grade MCAS. And let's start with this one. So number 2, Susan wants to hire one of 2 mechanics to repair her car, and each mechanic charges a one-time fee in addition to an hourly rate. So that one-time fee is going to be the y-intercept. Okay, so that's going to be what we would call B, the y-intercept. And the hourly rate is what we're going to call the slope. And we can put all that together in the slope-intercept form equation, y equals mx plus b. Now we're told some information about mechanic A, and then we've been given a table about mechanic B. So let's start with mechanic A. Charges a one-time fee. That's our B, our y-intercept there. Okay, and also, and we don't know what that one-time fee is, and charges $35 per hour, so that is our slope. We also know that it'll take 5 hours to complete. The job will cost $225. So we have an equation we can set up. Y equals 35, that's our rate, times x plus the unknown one-time fee. But we can find that unknown fee because we know how much the overall job will cost if 5 hours are spent on it. So we can go right into here, and I'm going to go ahead and solve this for B. That's the unknown. So $225 for the overall repair equals 35 times 5, which is 175, plus B. And then we subtract 175 from both sides, and we get 50 equals B. So we know the one-time fee is $50 for mechanic B. Okay, now, and we know, I'll just go ahead and also note that 35 equals M, and we've got an overall equation of Y equals 35X plus 50 now for mechanic A. Now let's consider mechanic B. Mechanic B has a table showing hours. So 1 hour is $80, 2 hours is $120, 3 is $160, 4 is $200, and so forth. If you follow up going on the cost, going up each step, it's $40 increase each step. Each one of these is plus 40, while each one of these hours is plus 1. So we can actually come up with a rate for mechanic B. Mechanic B has a rate of $40 per hour. So we're going to say Y equals 40 times X plus B. All right. You may be able to mental math that mechanic B's one-time fee is $40 from this, but we can also use the information. Any of the information on this table will do the job. I'm going to pick the 1 and the 80 because I can now replace Y with 80, and that equals 40 times 1 plus B. And then that just becomes 80 equals 40 plus B. And we can solve for B. B is 40 as I predicted. So mechanic B's equation is going to be Y equals, I think I'm going to just have to move this over here, Y equals 40X plus 40. And that's the equation that will define what happens for mechanic B. Now the question overall is how much more money in dollars does mechanic A charge for a one-time fee than mechanic B does? Well, the one-time fee for mechanic A is $50, and the one-time fee for mechanic B is $40. So we just have to do 50 minus 40 equals 10. So it's $10. $10 is what $10 is the amount more that mechanic A charges for a one-time fee than mechanic B. And that's the answer to that. Now let's go check out another linear one. I think I'm going to go down to number 5 now. Okay, number 5 is a different kind of question about linear functions. It's asking which of these are linear functions. Well, what you want to look for is x accompanied by an exponent other than 1. Now, if there's no exponent, we assume there is an exponent of 1 there. We just don't need it. So these all have exponents of 1. But this one here has an exponent of 2. And this one also has an exponent of 2. These are going to be parabolas. We're going to do that. These are quadratic functions. These are linear. So B, C, and E are all linears. E is a really simple one that just does that. Straight line, y equals negative x. This one has a y-intercept of negative 5 and has a reasonably flat slope of 1/2. This one has a reasonably steep slope of 2 and a y-intercept of 1. So those are your answers for that one. Now let's go and check out number 9. Okay, for number 9, we have a linear relationship expressed in a table showing a relationship between x and y. Now, first check out the x. The x is hopping up in steps of just +1 each time. So it's all +1, which makes things very simple because if it's all +1, what we really just need to do is look at what the y is changing by each time. Each time y goes up, it goes up by 2. So it's always +2, which means it's going to be +2 here as well. 1 to 3 is +2. And here, 7 to the next step will also be +2, which means the next step is 9. So that's 9 right there. 7 plus 2 is 9. If you needed an equation for this one, it would be this. It would be y equals our repeated step of 2 for 1, which would just be 2, times x. And when x is 0, y is 5. So 2 times 0 would be 0, but we still need y to get to 5, so we'd say plus 5. And that rule will work for all the other numbers. 1 times 2 is 2 plus 5. 2 times 2 is 4 plus 5 gets you to 9. Negative 2 times 2 is negative 4 plus 5 is 1. So that equation will work. But all you really needed for this one is this answer. Okay, I'm going to pause and go to another linear one. Now we're going to compare some graphs on number 11. And we will say which of the following graphs represents an increasing linear function. Well, since it's linear, we can cross these two quadratics out. They're nonlinear. And then we look at the two linear ones. This one is decreasing from the left to right, and this one is increasing from the left to the right. And that's what we mean, from left to right. And the slope is positive. In D, the slope is negative in C. So C is no, and D is yes. D is an increasing linear equation. Now we'll go on and take a look at number 14 and 15. So as you've recalled, I have talked about the y equals mx plus b equation a little bit in the others. Okay, and these are all in the y equals mx plus b structure. So let's consider what information we have. We have a line going through a point at 210. And it has a y-intercept at 4. That means it has a point at 0, 4. So that means we have another point as well. We also know what b is in this equation. B is 4. So that means we can rule C and D out because that's not a 4. That y-intercept, that is a y-intercept at 3. So we can cross these two out. They are not part of our list. So it's one of these two. Y equals 2x plus 4 and y equals 3x plus 4. All right, there's a couple ways we can do this. One, we can just test this point. If x is 2, then 2 times 2 is 4, plus 4 is 8, so y would be 8. That does not get us the point 210. And y equals 3 times 2, that's 6, plus 4. That does get us to 10. So that one works. This one does not. So the answer is B. I will note one other thing, though, which is that we could find what m is by just calculating the slope. The slope is the change in y divided by the change in x. And to get that, we just do a little subtraction to find the difference in the y's and the difference in the x's. So we have 10 and 4 as the y values. So 10 minus 4, remember y comes second in a point after x, and then we have 2 and 0 for x. And once I picked 10 as my first part of that subtraction, I needed to pick the x from the same point. So I've got 10 minus 4 over 2 minus 0, and that equals 6 over 2, which simplifies to 3, and that, in fact, is our slope. So that's 3. So that matches up with our choice of B. Y equals 3x plus 4. Y equals a slope of 3 times x plus 4. And we're going to take a look now at number 15, where we are given this question, which graph represents y, the cost in dollars of purchasing x pens at the store? We know the pens cost $1.50 each. That's a rate, which means that's the slope. So however many pens we get, that's x. You'd multiply that by $1.50 to find out what y is. Okay, so let's look at distractors. C is a distractor. It sets y as 150 no matter how many pens you buy. So you're not increasing anything. You're just like, I can buy 1 pen for $1.50 or 3,000 pens for $1.50. That is not it. D starts at a price of $1.50 with 0 pens and then goes up by a rate of $1.50 after that. However, that's not how this is working. We haven't been told that we're charged $1.50 just for walking in the store. So I should be getting 1 pen for $1.50 and 2 pens for $3 if the rate is $1.50 each. So this one is not it. This one here is saying we get 1.5 pens for $1. So it's flipped the script, and the slope is, instead of cost per pens, this is pens per cost, and that's not what we're looking for, and it's labeled cost per pens. So the only one that works is this one. When I have 0 pens, I pay $0. 1 pen, I pay $1.50. 2 pens, I pay $3. 4 pens, I pay $6, and 4 times 1.5 is 6. So this is the choice that we want. That is number 15. Okay, there's one more that is a linear type of problem. I'm going to go down all the way to it. It's number 20. I'm going to pause. You don't have to. So number 20 is partially linear and partially statistics. So we have a scatter plot. It's called a scatter plot because you plot points that you collect data. It's not necessarily going in a nice, tidy, straight line, but it does have an overall linear pattern to it. So we're looking at the total amount of money in a bank account at the end of each week for a period of 12 weeks. And because human beings are not robots, and we take money out, put money in, and so forth at various irregular rates on the short term, but in the long term, we get kind of regular rates oftentimes. That's why the data is scattered about, but it is scattered along roughly a line. So we could draw kind of a straight line of best fit if I were, something like that for all of our data, if that was a straight line. Okay, so which of the following statements is true about the scatter plot? The scatter plot shows one outlier. Well, that would mean there would be some point way away from a line of best fit. So no, it doesn't. There's no point that's like down here or something. The scatter plot shows clustered data. The data is not clustered around a particular spot. It's gathered around a line, so that's not it. The scatter plot shows a positive linear association. Well, it does show a linear association, and the linear association is increasing, going up to the right. It has a positive slope. So, in fact, this is the choice. Our best fit line does not do something like that. So this is not it either. So a negative 1 would have gone down to the right. I hope that was helpful.